Hi guys, in this video, I'll be discussing a system design concept called geohashing, which is used by multi-billion dollar tech companies like Uber to scale their Postgres or geolocation queries at the millions and billions of queries per second. Right. So this will be a one-of-a-kind video and the first video in the internet where I will be discussing this concept and then I will be implementing the demo in React Native, as well as I'll be creating the Postgres tables or the SQL tables in Supabase, where first I will insert 300 data points for testing purposes, and then I would be making a unoptimized query, and then I will optimize it with the help of the geohashing concept, and then I will render all the points onto the map in both React Native maps and then Mapbox. Right. So let's get into it. So this video will be extremely long. So take your time to understand and absorb each and every concept. By the end of this particular video, you will be able to do the full stack implementation of a delivery based app, right from the backend to the database to how to optimize it for millions of queries, and then render all those data points onto the your app which your users use, right? So let's start. So first I will discuss about all the concepts related to this, and then what we will be doing step by step, and then from there how we will be converting the backend queries, and then like calling all those API points in the API endpoints in our React Native application. So let's start with a business statement, right? So if you have used an app called Zomato in India and then DoorDash in the USA, or your own delivery-based apps in, let's take in I think Singapore, you guys have Grab, right? It's a multi-billion dollar app where they use the same concept that I am going to explain here. So let's take, you want to order some delicious dishes from your house, right? So I'm going to provide you a question where I'm going to ask you, how can you find hotel or delivery agents near your place? So let's take, you are in Chennai. That is a place was born at. Now from there, I am at a particular locality, and then I want to search which are the hotels which are 5 kilometers in radius from my own place, or 1 mile is 1.6 kilometers. So you can take us 3 miles. Right. So let's say, as I'm Indian, I'm just going to use kilometers throughout this video. So, but I'm just going to enter as 1 mile equal to 1.6 kilometers. Right. So what I'm going to do here is I want to find the hotels which are around me. So that is the first question. So which are 5 kilometers within my place. So what I can do is, let's take in, this is a system design concept, right? So for now, what we are going to do is, there are 100 hotels which are at 500 5 kilometer radius from my own home. So as I want to find it, you can do it in two ways. Like, you can do it in multiple ways, but the first way will be an unoptimized way. Or what you can do is, let's say you have 100 data points. So let's go here and then search as, you have 100 data points. Let's say for our use case, we will use it as 300 hotels around your home, which is in 5 kilometer radius. You know it in your mind, but you have to technically get all those values and show it to the user in this map, right? In React Native or in Shift or whatever it is, you have to show it there. How can you do that? Right. So how can you do it is, the unoptimized way will be, you like from your location, let's take it's in 34.00, and then the latitude would be 120.00, right? This is your location. So you can individually find the distance between your home, which has these coordinates, to that restaurant one by one. Okay. So in that big O notations, right? So that is also a system design concept where it will linear scale or exponential scale, all these things would be there. But here, if we go with the extremely unoptimized way, you can as you have 300 data points of the hotels, or the 300 hotels in your database with latitude and longitude, you can find the distance between your home and then the hotel, and whichever is less than 5 kilometers or 5,000 meters, you can just render it onto the map. So this is one extremely unoptimized way, but this also works for very, very less amount of what I would say, like, data points. What if your app scales for what like thousands and thousands of restaurants and then delivery agents, etc.? This is extremely unoptimized way. So in order to tackle all these things, we can use a concept called geohashing, right? So what is geohashing and how we can implement that? So this person has made it work, like he has provided a full blown explanation on that. I learned from him, so I'm going to explain the important bits he has said here, right? So before that, what we'll be doing is we'll be creating a table here in Supabase for a real demo of the both the unoptimized and the optimized queries with geohashing. So here what he has said is how to find nearby entities. So our problem is the same on how to find the nearby hotels or restaurants in from my own place in Chennai, right? So now what I can do, he's saying all these things are there. So the first one is the brute force method that I have said, and then next is the geohashing algorithm. So how we can like make it work, and then how we can optimize this very bad query that I said before. So as he said, geohashing is a method of encoding the geographic locations into short strings, right? So what is that? Like it's like too much jargon, but I will explain it clearly. So if I scroll down, I think he has provided a nice website where I okay. Let's from here. Let's see. So in this section, for the geohashing concept to work, the whole world is divided into quadrants like this, right? And then what you can do is you can recursively go into that quadrant, right? And then you can like for example, the whole world is like in a map, it's flat. So they have divided, the mathematicians have divided it in this way. And then if you go into a particular quadrant, and then it would, divide it in this manner. And then you can go up to the level of 12. Okay, so this is the level 0. From level 0, G0 to G12, you can divide the particular map or the quadrants in this manner. So it's G1 to G12, right? So if I do this, so the for instance, this one contains 1, 2, 3, 4, 5, 6, 7, 8, right? So 8 into 4 is 32. So 32 quadrants at the top. Each quadrant's like what a grid area is 5,000 kilometers, right? You can go into that. So you can divide it by 4, right? Like you can like that is some other algorithm, but it gets reduced one by one, and then it will go to the least level of G12. Okay. So what is this and how we can use that? So as I said before, if there are 300 hotels, let's say in your database there are 1,000 hotels, right? So you have to manual like technically you have to find the distance between your hotel, that your place and that hotel for thousand hotels, and then only 300 hotels are less than like 5 kilometers, right? So what you have to do is you have to return those values. Like first you have to select all the values from the Postgres table, and then manually run the function there, and then you have to like show it in the maps. That is extremely unoptimized. But what you can do is I will tell you a superb way. Okay, in the geohashing concept. So as the world is divided into this G12 or 12 different types of geohashing algorithms, right? In this manner. So for example, what he's saying, for instance, a geohash with 5 characters might cover an area of around a few kilometers. So he's saying of 5 characters. So in this manner, at the top, you can see this is the geohash string. Okay, the geohash strings has 1 character until 12 characters. Okay, so from G1 to G12. Okay, if I go here, so this was the link that I wanted to check. So if I go here, geohash explorer. So I'm going to show that in this manner. So I'm going to go to F, and then I'm going to go to my place. Here, this is my place. Okay, so I'm not going to dox myself. And then let's take I am like let's go to Royapeta, right? Like here. And then you can see in the GeoHash Explorer, for each quadrant I am going forward, like going inside that, it keeps on like adding that value there. Okay, I can still go inside this. Okay, and see it keeps on adding. That's how I can do it. So if I tap on go, so I think yeah, from G0. So if I go out, so from G1, this is G1, and then I can go inside all these quadrants to go to my own city and to my own area. So why is this useful? Why we should do it, and how it optimizes our own queries, right? So let's take from from a developer sense, right? From a developer point of view, where you have not discussed any system design, or just a full stack developer, where you can properly like create data points. You can update it, delete it, doing all the CRUD operations in the backend and the front end. You can deploy all your code, backend code, and then you can consume it in your front end, use all those things. Okay. Now this is the point to upskill yourself to the moon. Okay. In this manner, what we are going to do is, let's take you have 300 hotels, or let's say for now 1,000 hotels, data points, right? And then data points. So how would the data structure be, right? It should be name. This is hypothetical. Okay, this is name, and then should be latitude. This should be longitude, and then the other one would be, let's take address. Okay, now you simply add it, and then in the let's say it's NoSQL means Firestore and then MongoDB, etc. In SQL databases which are relational, it would be what Postgres or MySQL. In like it works in both ways, right? So these things would be added as a row in a like relational database inside. Let's take restaurants or a hotels table. For NoSQL, it would be, you would be adding these particular values as a object or as a document in NoSQL. Okay. So for now it's Postgres. So what I'm going to do is, in the Postgres SQL table called geodata, there are 3,000 hotel points or hotel data points which has their name. Let's say KFC, and then address would be somewhat in Rayapeta, right? And the latitude and longitude would be something in this manner. Now it's some simply like that. And then what you can do, you can select star from this geodata table, and you can select latitude and longitude, or select name from geodata table. Okay, that's normal SQL function. If you're a backend developer, you can understand it fully. Now from there, what we are going to do is, we have in the previous video. So if I go back here, so this is my 7th part of the Geoverse series, right? In the previous video, I would have explained the same, like in a place called I think if I go to the top, I think, sorry, this is not the code. Okay, so I'm going to go back to here. This is a demo application, right? So here, so I'm going to close all these things. Here in if I go here, animate to geo, I think, okay, so I'll use geolocation. Okay, here. So what we are going to do, we can get the coordinates of the particular user with the help of the geolocation.get current position and get their latitude and longitude. Okay, so we have this somewhere in our front end side, and we can also put this in the back end. Okay, so now as we have inserted 3,000 restaurant or hotels values in the Postgres table, from there we can query, as I said, in an unoptimized way. With these with this latitude and longitude, we can use a formula called Haversine. Okay, so Haversine uses the the Earth's radius, and then all those mathematical formulas to find the distance between two coordinates if the latitude and longitude are present. Okay, so what we can do is, we can select all the data points from geodata table, and then we can loop it with await promise.all, and then we can put that in an array. Okay, so the values we retrieve will be in an array, and then we can put that in. We can find the distance between the user's coordinates, and then all these latitude and longitude values, and then we can output it. Extremely unoptimized, extremely wrong. Okay, so how we can improve this, and then how we can do it in how you can also implement in your own applications, right? So here, as these guys he's saying just simply use geohashing. Like, how does geohashing work? Each rectangle can be divided into a small number of rectangles. I said quadrant, like, you can also use it in any way, right? So the for now, I'm just going to use that rectangle. So each rectangle will be divided into sub-rectangles, and then G1, G2, G3, etc. So, all these things, right? So as we move forward, so if I tap on this is the third level, right? So if I tap forward, it would be the 4th level. This particular algorithm, the funny part is, this particular algorithm is already defined by mathematicians and computer scientists way back. Okay, when they devised this pattern for geolocation concepts, like for implementing geolocation in billions of users. So once we let's take if we have the coordinates or latitude and longitude, we can use a library to just simply get the geohash value. Okay, as these things are already defined by someone else. Okay, so as these things are already defined by someone else, when we are going to add the, what I would say, the hotels or the restaurants values or any geolocation values into our database, we can, like, what we can do is we can get the geohash from these two, and then when we are going to add those values as a row in the Postgres, we can also use something called geohash and then add that geohashing values, geohash string. So that would be TFF or something. So we can, when we add, we calculate the geohash, and then we are going to use it as another data structure, and then we are going to append that row inside our table. Okay. So why, if we do that, we have already done 50% of the work, where each and every row would have a geohash string. Okay. So the thing I think here is, as you know, let's take, I go here, right? So if I go into my own city, so just start my city, not this. Okay, I'm going to go out here. So if I go here, if you see carefully, so this is G4 and then G5. So one G5 and then this is G6. Okay, I just need for G4, G5 and G6. Why? Right. So if I go to the top like this, in this manner, so this is G5, right? So G5 means 5 strings are there. So this is this, but whole quadrant is a whole rectangle here would be my city. Okay, so if let's go to the top, and then let's reload. Okay, this is it's going too much inside. Okay, it's caching the value. So let's take this out. Okay, now let's go inside 1, and then here 2, and then here 3. So we don't 3, and then here 4. So this almost covers all the parts in my city. Okay, it's around the beach, so these things we can exclude it. So we don't need G1, we don't need G2, we don't need G3. We just need to start adding the values of geohash from G4. Okay, this covers the entire city. Now, if you still want to go into it, so what you can do is you can go here, and then this covers my area as well as all the areas around me. Okay, almost 80% of my city. If I still want to go more into my area, I can use this G6. Okay, this almost covers my particular areas. What I would say, geohash, right? So why I am saying this, right? If I scroll down, no, here, how is this helpful, right? So okay, I will explain why we need to use G4, G5 and G6, as it's an optimization, as he has said here. Now, as you know, it for G1, G4 and G4, G5 and G6, we are just going to use 1 kilometer, 5 kilometer and 10 kilometer. Okay, that would be the range, or that would be the area that particular geohash is covering. Okay, we don't need to get the values which are more than what I would say, more than 100 kilometers, right? That is not required, right? So the 100 kilometers is what I think 70 miles, right? Will you order from 70 miles away? No, you will be ordering at least 15 kilometers or 5 to 15 kilometers. Let's say from 1 kilometer to 15 kilometers, right? That's what you are going to order. So once, when you add the values to the database, what you can do, if as you already have the latitude and longitude of the restaurant or the hotel, you can simply use it in this manner: geohash 4, geohash 5, and then geohash 6. So geohash 6. Okay. So you are going to, whenever you add the data points in the admin side or in the app side, whatever, in any front end application, or you are going to feed all these values, you just get the G4, G5 and G6 and add it to the database. Why we are doing all these things, right? So we understood all the concepts here. I'll also recap it once I finish this. Once you do all this, why we need to add the G4 or G5, G6? And how is this useful for querying the data points and to get it, right? Now I will say you why. So let's take this guy saying McDonald's and Burger King. Both are I think they are in Chennai. So if I go here, I got the user's location in React Native. It would be different for Android. It would be different. Sorry, Android means in Java or Kotlin, Swift, or Kotlin multi-platform, or also in web, right? So in React Native, you can get it with the help of this particular library called React Native Community. And then once I got it, So what I can do is I can geohash this particular coordinates value as well, and then I can have that particular geostring. Okay, so I have a geostring here. I have the geohash here. I also have the geohash in my database. So what I can do, I can so if I go here, I can use the like operator in SQL to check if this particular geo has where in this particular geo table, I can query if whatever the geo hash is in my database is equal to or is like. Okay, it is case sensitive and the case insensitive and case insensitive, right? So you can use I like or like. Okay, so for now let's take we use like to check if this particular geo hash or whatever. Let's take we have t this one, right, and this one and my this geo hashed value is similar, any values are similar to my similar to this geo hash, and then return all the values. Okay, so you see what happens here. So as we have, so I'm going to go here. Okay, so avoid promise, that is to get all the values and like find the distance one by one. So for the geo hash, what I'm going to do, as I have the users geo hash, so as I have the users geohash, and then I'm going to use the like operator to find the geohashes which have the same value of this in the database. Okay, and then I'm just going to return those values. So here what happens is a single query with no overhead will get all the values from the database, and we can paint all those values in the app. Okay, so these all these unnecessary steps which we had before by doing it individually, it would take a lot of milliseconds, like a lot of seconds itself to finish this query. This will immediately return the queries, and if we properly index it, it will do even better. Okay, so now as you know, like if we like by using this particular concept, we have optimized our query by thousands of times. Okay, so that's how what that is the benefit of using geohash in your like understanding the concept of geohash in system design. Okay, now this guy is saying store only G4, G5, G6. So that's what we are going to do now, and then serve your reads from cache. That is out like very advanced concept where you would be having a Redis cache or a Valkey cache, which is the latest one. Where what we are going to do is let's take this slightly advanced system design, but if you know this, you can make your apps much faster. I did the same thing in my apps. Okay, so it was slightly slower. Some API responses were slower. So I identified these particular data points will not change again and again. So I will simply put that into cache with the TTL, which is time to live, and then once the first time the value will be populated in the cache, and then for the next time I will just get the values from the cache which has increased my app speed multifolds. Okay, because serving the data hot from the cache is always faster. Right. So rather than going to the database and then getting the values and returning it. Now the difficult part is in cache invalidation, but we have to have proper triggers so that when the values change, we have to update the cache as well or purge all the caches. So I'm getting ahead of myself. So that is one more concept. So here there is an edge case here which I will discuss at the last. Okay, so that is the last part of this article as well. Now to recap all these things, so that we will be entering into Supabase's thing dashboard, and then we are going to create a table, and then we are going to do the unoptimized way, and then we are going to do the optimized way of how we can query it, and then we are going to see see all the markers in the like what I would say like in the React Native app. We are also going to see the response time which is taking from the start of the query to the end of the query. Okay, so let's start. So let's recap this and then start there. Let's take. I'm going to recap this with one more additional concept, right? So here. If I go here, okay, here what I'm going to do is I'm going to do one more concept with the delivery agents. So you have ordered your like nice dish from KFC, right? You have ordered Zinger burger from KFC. Now, how does Zomato or DoorDash, get like find the delivery agents around that particular KFC hotel? right? So this is hypothetical, okay? But I assume they would do in this manner. They can do it in their own manner because they have system engineers, like principal engineers who have been coding for 15 years. I'm just doing it for 5 years, but this is my assumption on how I would do this and how they would have done. So let's take, if I go back to this simulator, that would be more easier. So hypothetically, I am in, San Jose, right? So let's take, I'm going to scroll in. So in this way, so I am in, what I would say is I am in Dana, right? Or Rose Garden. Okay, so my home is in Rose Garden, and then I bought it from PayPal Park. Okay, so let's say I bought it from PayPal Park. Now, in this way, so in this, like, this table is another table called delivery agents, and then once I have like done all these things and ordered it, the order will go to Zomato's dashboard or DoorDash's, like, admin dashboard or in their backend, and then the hotel will approve the order. Okay, from there, what let's say it takes 5 to 15 minutes to do the order. So at the 10th minute, what the DoorDash or the Zomato's backend has to do is it has to find a delivery agent who is 500 meters from this place or 1 kilometer from this particular place. How will it do it? Okay, so this requires too much concepts to be implemented, but I'm going to say it in React Native style. Okay, on how I would approach it, right? So the delivery agent would have another mobile app. Okay, where his location would be emitted to the server with help of React Native background location. Okay, so what we will be doing is there's a library called I think React, the same library, sorry, this same library where I think here, so geolocation dot, so I can see watch position. Okay, so with help of this in the delivery drivers app, I'm going to watch position of success. So position, and then so position dot quartz dot latitude. Okay, so let's keep it as this one. So what happens is whenever the driver moves, right, like he has gone into the app, in the delivery app, he has started like start session or start driving session, right, and then start delivering for today at morning 10 a.m. or 11 a.m. What we will be doing is in the React Native side, we'll be getting his latitude and longitude values with help of this particular function, and we will be sending these values send to server. Okay, we'll be sending this value to our server with help of WebSockets or some other long polling, etc. Okay, now as this particular value is in the database, so when the user, when the when the restaurant is about to complete the order, we will be checking which driver or delivery agent is around this particular restaurant. Okay, so who's 500 meters or 1 kilometers from this particular restaurant, and we would send FCM notifications to. Okay, or SMS. I don't know how they do. I think they would do it in three ways. One is SMS, where when they tap on it, they deep link into that particular order page, and then they accept it. Notification the same. They can FCM notifications or APNS. For Android, it's FCM, and in Apple, it's APNS. Third is in-app notifications. They would have some triggers to do that. Okay, any three. Okay, for the SMS, they would be using something called apps flyer. Okay, they would have dot one link dot me, right, something like that. Now, once I tap on that, they would go there and then they would accept the order and that flow. Okay, so the same concept can be used here. So what they can do, let's say they have thousands of delivery agents around the world. If they go with the unoptimized way, they have to go to each driver's values and then get the select and then use filter in React.js or React Native, or mainly it's React.js concept. Sorry, it's a JavaScript concept, and then from there they have to get the the deliver driver's location, and if it's less than 1 kilometer, which is what like 500, like 1 kilometer, and then from there they have to send the notification to, and then they have to do it. That is extremely bad, extremely wrong. So what you can do it in a better way, where when the values are sent to the server as the delivery agent's location, what you can do is you can add the geohashing values that is said here, the geohash 4, 5, and 6, and then you can simply select name, latitude and longitude from the delivery agent's table where the geohash 5, or we can also do one more with geohash 6 because it is very near, right? So if I go here, so geohash 6 is 1 kilometer and 500 meters, so it fits perfectly there. So if the delivery agent's geohash 6 is equal to, or like it is similar, it's equal to the values in the database, or from the restaurant's geohash, which is always static, you can simply send the notification to them. And then if one does it, then the order will be sent to them. Okay, that's how you do it. Okay, that's how you can optimize it in real world, real concepts. I don't know how they do it, but I would do this in this manner, as this is an extremely well made geohashing concept, system design concept. So these are all the theory you need to understand for this geohashing, which I have now done with this particular superb article here, and then with the React Native app. Now let's get into the demo. So for the first part, I will be discussing about how to create the tables in the Supabase with their SQL editor here, and then we will be using the Supabase credentials, and then we will be plotting all the coordinates in the React Native side. So for that, I already made some notes here. In this one, so let's copy this. Okay, so we are going to create a table. So let's copy that and paste it here. So what is this? Create table geodata. So we'll be getting a table of geodata, and then we'll be having an ID because each and every element should have an ID. And then latitude and longitude, they would be in float or like double or like decimal points. So we'll be using that. And then geohash strings will be used here. Okay. Now what I can do, I can tap on run. So a table will be created. So success, no rows written because we are not selecting anything. Now in this, what we have latitude, longitude, geohash 4, 5, 6. So we have created a table. So if I go to the table, this is the demo app. So RLS is not enabled. So you have to enable RLS for your application. So if I go to the geodata table, you can see I have ID, latitude and all these good stuff here. Now I'll go back to SQL editor. Now what I'm going to do is here, I before like simply use the whole geohash values, but for now I'm just going to use these four for fine grain tuning. Okay, why? Because geohash. Okay, he has also told the same thing. So I'm going to go here. So do we need to store 10 length geohashes for every place? The answer is no, because we don't want, like, this is how you optimize for millions and billions of queries. Okay, so as your database grows, right? So if you have like Uber's, how many drivers around the world? It's in US, Canada, Australia, India, and everywhere. So if you store that 10 characters one, which you are not going to use and it's not necessary, you simply use the 4 and 5 and 6, which is slightly better, right? So or you can optimize it further by just using Geo5 or like hash 5 or hash 4. Okay, so that would decrease the database's size in the long run, as you have optimized it in the starting itself, which is a fundamental concept of understanding system design. So once that is done, what I'm going to do, I'm going to go here. I'm going to create the extension called geohash. So I'm going to go here. Let's replace this, run. So, okay, sorry. I think, yeah, sorry. I'm not going to use that. I'm going to use this one. So I'm going to go here. Sorry, here. And I'm going to copy all these things. So, sorry, here. So what is this? What I'm going to do here? So in Supabase, they have provided an excellent way to handle some handle some functions or some complex queries by creating it as a function. Okay, so if you create this particular function in Supabase, right, what you can do is you can do a remote procedural call or RPC, right, where you are simply going to call this and then you are going to add the the latitude and let's say when this particular function gets triggered, what happens is the okay, you can see create or replace function, return trigger as begin. So geohash 4, 5 and 6 and return new. So what happens is when you insert a row inside your inside your inside a table, this particular function will run, and then it will automatically encode the latitude and longitude in G4 precision 5 and 6. Okay, so you can do this in multiple ways. Okay, so you can either in the data is being added from the front end, you can use a library called Geohash. So I'm going to go Geohash. Sorry, not here. Geohash. Okay, so Geohash npm. Okay, so you can use. Sorry, I think you can use this particular library called n node geohash, and then you can encode that, and then you can send it to your backend, right? So precision, which is 9, like you can also use 456, or you can create this particular function which will get triggered when a row is added to the geodata table. So if I go here and then let's add everything. So let's go here, add, run. Yes. Okay, so it has successfully ran. What is this and why I did? I explained it now. So whenever the row is added, Supabase will automatically trigger this particular what I would say function when a row is added, and then it will take the latitude and longitude column value of that particular row, or what I would say row, and then geocode it and then add it to the G5, G4, G4, G5, G6 values, right? So let's test it. So that's it. That's the simple setup for creating the table, creating the functions. As I said, you can do it in 2 ways. One in the front end by using this particular library. Second way is like triggering the values from the Supabase triggers. I use Supabase for all my projects which uses relational database. So this is more comfortable and they are extremely good. So now what I'm going to do is I'm going to create 300 data points around California. Okay, or what I would say, yeah, around California. And then let's see. So let's go here and so I'm going to go here. Let's copy all these things. So this is a function to do that. Let's go here and then in this manner, I'm going to go here. Okay. So let's go in this place. Let's use hashing. And then for the geohash, as you know, for now, as I'm a more front-end inclined, I'm just going to use this particular library here. Node geohash. So I'm going to go here, use npmi. Okay, once I do that, let's go here, geohash. Okay, it's not okay. So okay, let's in this one. For now, I'm simply go. Okay, so I've already retrieved the coordinates for California, and then I'm going to generate the coordinates randomly. For now, I'm simply going to generate 4 coordinates, right, to test if this is working or not. I already got the Supabase credentials from my own database. So if I go here, I already got the credentials for this, and I have inserted somewhere in the utils. So I'm going to go here and simply call that. Okay. So yeah, in here. Okay, so I got that. Now I need to get this working. So I'm going to copy this. Let's go here to the top. Just simply use it, and this should be in import geohash from geohash. Okay, so let's get this. And then, as I said, this is the coordinate where latitude and longitude. This is the longitude and G4, G5, and G6, which is the precision of 4, 5, 6. And then we are going to insert that there. And then for now, we are going to use the name as math.random. Okay, because if I go here, if I go to the top, okay, they don't have a name, so no problem there. So there's a function here. So what I'm going to do is I'm going to create another button. Let's go here and copy and paste this. Let's use 100 and then generate coordinate values. Okay, generate coordinate values. So this is at there. Looks nice, but still I'll use this one. Now one more is in this manner. I'm just going to go here and use it there. So let's check if this is working or not. So let's tap on that. Let's see what is happening here. Nothing is happening. So we'll go to the table editor. And then in geodata, things didn't get loaded. Okay, I think let's go insert geodata. So okay, sorry, not here. In here, let's go here, and it should be generate coordinate values. Let's go here, and then they already have a reload function. Refresh. Yeah. Okay, so you can see coordinate 3 function geohash encode does not exist. Okay, so I'll go here, SQL editor, generate geohash. Line 1. Geohash encode. So okay, let's add the values and then let's go to the Supabase table and then see it. So if I tap on the generate coordinate values and then if I go here and if I reload it or refresh it. So let's refresh it once more. Okay, so you can see 3 values are there. Now to make it work even better, and then I'm just going to go and then insert 296 values. So I inserted 296 values with all this geocoding, etc. So let's reload so that all these error messages go out and doesn't clutter the view. Now if I go here, let's tap on this generate coordinate values and then we will have 300 restaurant or hotels data points in the dashboard. So I'll tap on this so that it looks better. And then now I'll tap on generate coordinate values. It will keep on generating all the values in the for loop. This is just for demo purposes. We are just feeding the data with dummy data points. With if you see here, we have G4, G5, and G6. So as I said, you can do it in 2 ways. If you don't want to add the geohashing values in the front end, you can create the triggers and make it work. Or you can do it, you can simply add or generate the geohash in the front end and send it to the backend. More optimized ways is in the backend when a row is added, the database will automatically take it and append those values here. Okay, so I think it should have worked. So now let's refresh. Okay, it's already refreshing. Now I'm going to okay, it's there. Okay, 196 and all these things. So for now, I think we have refresh. Okay, it's adding. Okay, let's put it in that way. So what we are going to do is we are going to do 2 things. One is the unoptimized way and another is the optimized way, the brute force way. Okay, so let's go here and then I'm going to go here. So let's go to the SQL editor. Let's replace this. So what? Select ID, latitude, longitude as distance. Okay, so what we are going to do, we are going to this is one. We can also optimize this further, where as I said, we are going to get the lat and longitude values of that particular user in this manner. So not here. Where is that? I think geolocation dot. So geolocation dot. We are going to get the value, latitude and longitude values of that particular user, and then we are going to find the distance between that particular coordinates and then the restaurant values, and then we are going to get whichever which is less than 5 kilometers, right? So let's get into it. So here in here what we are going to do, so sorry, here let's create a function in this way, animate to, let's take this and then let's create a function called async function get get distance in unoptimized way. So unoptimized way equal to this. Sorry. This should not be in this way. Const get distance or get hotels in unoptimized way equal to, this should be an asynchronous function because we are going to call the database. So let's go here and then let's go to the SQL editor. Let's replace this. So what? Select ID, latitude, longitude as distance. Okay, so what we are going to do, so let's go here and then let's go to the SQL editor. Let's replace this. So what? Select ID, latitude, longitude as distance. Okay, so what we are going to do, we are going to get the lat and longitude values of that particular user in this manner. So not here. Where is that? I think geolocation dot. So here what we are going to do is we are going to get all the values set. So get places equal to Supabase dot.
Yeah, got it. So
We're going to Supabase dot this particular table, which is geodata dot select. Okay, we are going to get all the values, and then we are going to get all the values, and then we are going to find the distance between them, right? So let's go here, use const like places which are near equal to await promised dot, actually this should be await. Okay, promise dot all, and then this should be places dot, sorry, places dot data dot map. Okay, so we'll use it as place, and then for now let's use console dot log place. Okay, and yeah, so let's, okay, I think this is not required anymore, so let's use this. Okay, we'll use, okay, so we'll use it in this manner, and then let's see what is happening. So I'm going to go here same way. So the values are already generated, so get in, get data. Okay, get data. So let's check that is working or not. This is for testing purposes. So now I'm going to tap on get data. So we got all the data points. Okay, we got everything. Okay, so now what I'm going to do is I'm going to find the like, I'm going to do it in the unoptimized way, where I'm going to check the distance from the user's location. So where is the user's location? So this one. So I'm going to get the distance, like from the user's location. I'm going to find the distance between the user's location and then the restaurant's location. And then if they are less than 5, I'm going to append one. I'm going to check how many coordinates are less than that. Okay. So if I go here, and then what I can do, let's in this manner, let's use it in this way.
Yes.
And then for this, we need to get the Haversine formula. So I'm going to use Haversine formula. Okay. In JS. So using the Haversine formula, some gentleman has already written it. So find.
Such now.
Okay. So let's get this.
Yeah. You.
So we have this Haversine formula, and then I'm going to go here in this Haversine one. So as we already got the latitude and longitude, and then this particular things here. So let's take all these things out, and then we have the coordinates. So this is also const distance thing. For now, let's use limit thing. Called okay, limit of 10, so it will not go out too much. So const distance equal to Haversine distance, and then as we have the quads of one, longitude and latitude. So this guy is saying it in this manner. So we'll go to the top, get these, and go here and use this. Okay, and then one more is what, place dot longitude, place dot latitude, and then we are going to first console dot log distance, and then the miles is going to be false. So let's comment this, and then let's go here. Let's click on get data. Okay, so it's not running. So Haversine distance, there should be some mistake here. Get promise. So info dot quads, place dot longitude, distance. Okay, we got the distance. Okay, so you can see actually how slow it is. Okay, it was extremely slow. So it says what? It's in. Okay, it's too long. See, it was so slow. Right, it's still running. But let's see. Let's go here. There is a way we can find the the response time. So const response equal to new data dot get time, and then response time, response start time, and then I'll go here use const response end time equal to new date dot get time. Okay, so let's see what is the time response end time dot response time. Okay, you'll see now the difference. What I'm trying to say. If I tap on get data, okay, so you can see it's taking a long time. Okay, so you'll see how unoptimized this particular solution is. You have to do it again and again and again for this to work. Okay, or and then your user will get angry and then you will go off your particular application. Actually, you have to go here. So let's reload. It's something got stuck. So I'll go here and then tap on get data. See, that thing is not. So console.log response time. Okay. This is equal to of limit of 10. Okay, for some reason it's not working. So we are going to use this technique data.error, and then we are going to go here and change this to data, and we are going to log this value console.error. Okay, that's how you debug your production ready applications. So get data. In data is null, but I think the values too. It's taking a long time to get all these values out. Okay, it's parallelly processing all those values. So I think let's say so dot log distance. Okay, I think this is wrong. It's not equal to, it's minus. Okay, minus. Let's go here. Okay, I can see the value is there, and then here we'll get the distance and then the response time. Okay, so what is this? Let's go back. Let's tap on the get data. What is the like the starting point to the ending point? Actually, this should be here. Let's put it here and then tap on get data. 6 milliseconds, 7 milliseconds, and all these things are there. Okay, so let's check what happens for 100 data points. 100 data points unoptimized way. I'll go here, tap on get data. This is await promise.all. It's already an optimized way because I know promise.all runs parallelly. Okay, so everything runs parallelly. The values are there. If you run it sequentially, you know what would happen. So this is extremely unoptimized way. Now I'm going to show you how you can optimize it with the geohashing concept which I have discussed here. Now I'm going to go here and then in this side for this particular hash to value, let's comment. Okay, let's take all these unnecessary things out, and then now I'm going to use this particular function to hash these values. So I'm going to go here and then I'm going to use this quotes. I'm going to get the hashing values for the 4th, and then I'm going to get the hashing values for the 6th precision, and let's console.log it. So let's just simply convert this to 5. Use console.log geohash of 4. So if I do this, actually it's not 4, it's 6. Because let's find it because we have it in a bigger way, right? So geohash of 6. I'm going to go here and then tap on geodata. We got the geohash. Now what we are going to do? We are going to go here and then we are going to put this here, and then we are going to use dot select.
Yeah.
Select everything that from that dot I like of what column is geo hash of 6 Sorry, it's not geohash of 6. If you go to the if you go here and then if I go to the table editor and then geodata, so it's geodata geohash underscore g6, right? So geohash underscore g6, okay, comma, so pattern of what, this one, okay. So once that is done, let's go here and get the data points, data comma error. Same way we have this, so let's go here and no need distance, use it like this, okay. If we do this, if we go here, let's tap on get data, what happens? Okay, we'll go here, use geohash data, okay. If we use geohash data and then let's tap dot get data again. So Supabase geodata I like of geohash 6 of geohash 6. Okay. Okay, let's reload and check. Okay, at the top it's working, at the bottom it's not. So encode geohash. Okay, this error is not found. Okay, so you can see. So I debug. Now if I tap on that, you can see I already got this geohash and then all these things are there. Okay. Now what we can do is we can again go back, as these values are too far away from my own location. I'm going to go to the top, I'm going to tap on device, and then in here I'm going to I think, yeah, features, location, custom location, latitude is this, and then copy this value, I think, sorry, what is this? Okay, and then longitude is this value. Okay, so it's in Los Angeles now, so let's test. So this is how you test in full stack applications. So if we go here, tap on get data, it's like finding the values, and see, we got it. Okay, so we got that particular value, or I think we got geohash of 4, 5, 6, and then we got this value. Okay, so this is extremely useful for big applications, like for example 6. Okay, I think shouldn't be 6, it should be 4 because we want a wider range, right? So I'm going to go here and then change 5, and then this should be geo5, and see, I like, because 6 is smaller and 5 provides a bigger window, right? So if I tap on that, let's go to this, tap on get data, and I think it's geo5 5. Okay, so let's go here, get data, geo5 geo-g5, right? Geo5 5. Yeah, so that's how you make these things work. So if the geohash value is same, geohash 5 value is same as the user's value, right? The values will get printed out, and then now it okay, like one more thing is, as we already got the hash locations, to complete the full stack integration, I'm going to go here and then I'm going to add something like const hotel markers comma set hotel markers equal to use state of this, and then I'm going to go here, I'm going to simply use this data. Okay, I'm going to scroll down. Oh, this is map view. Okay, so okay, then okay, we'll also see how we can do it in normal as well. So here in this hotel markers, let's go here, use this value marker, and then I think for my other thing I have used the same okay, marker view. Here I'm simply going to steal the code from here, use return, and then simply paste it there. So for the coordinate values, this would be what? This would be for marker dot longitude, and this would be for marker dot latitude. Okay, so if I use marker dot latitude here, let's do that. Let's go back. Let's tap on get data. Okay, so image is not found, so I'll get the image from there. Let's do that. Click on get data, and I can see I have plotted all the values there. Okay, so to one up this, let's go here, use G4, and then let's get the fourth one, G4. Everything should be what? Not this. Should be G4. Let's get the G4 values. Now go here, tap on get data, and see, right? So that's a full stack implementation from here. Okay, so if I want to, as you know, like this works extremely well, and the response times would be less, even if it's for huge amount of data. Okay, but for smaller data points, or so for smaller data points, you can simply use the average formula. But for the huge millions, or like let's take thousands to hundreds and thousands of values in a city, there may be thousands to 10,000s of restaurants, right? They're extremely difficult to do it. Or else the main reason is, if your app is global, and then if you use the average formula, like it won't work. If you use the geohash formula, or the geohash concept that I mentioned here, it would work very well. Okay, so you can do the same thing in React Native maps as well. So that also works the same. Okay, so for that, what you have to do is you simply have to use the marker prop there, and then you can get this working. Okay, if I tap on this, it automatically animates, etc. Right? That's another front end concept. So that's how you do these full stack implementations for your own application, right? And then in the, like, you can create triggers in the backend. You can also geocode your values in the front end, and then you can add it to the backend, etc. Okay, so that's it for this particular video. And then there is one more concept that I missed, which is the edge case. To fix this edge case, I'll be making one more video on the concept called PostGIS, where I'll be doing the same concept in React Native Maps. This is for Mapbox. So here, what is the problem is, if the users are just close or on top of the grid line, right? So whatever grid line we are here, if the user is at this point, this particular algorithm will not work, and the users will be missed, or the restaurants will be missed, which will lead to loss of revenue. So this one provides a, what I would say, it's a like overview, like what I would say, like, it's not a precise or approximate value. Okay, approximate value, it just considers it with the geohash string of that particular restaurant. Okay, so to overcome this particular edge case, like where, for example, if it is in here, right, we have to get the geohash of the north, like 8 geohashes we have to get for the north, south, west and northeast, northwest, southeast and southwest. You have to check with all those things, which will further add on top of this query, and then the query will be slower. To solve this, there is a concept called PostGIS, where we'll be using their functions to get that working. Okay, so I think this is the first video in the internet where it discussed from scratch on how to implement the delivery and the hotel concepts, where you do it with the Avicen formula, and then you use the geohash to query the data from the backend, and then render all the markers over the over the app, and then how you can improve your response time so that your users get a blazing fast experience. Okay, so this is how you implement system design in both backend and then in the front end to make a full stack application which will provide revenue for you as well as for the restaurants, and then a good user experience for your users. So that's it. If you like this video, do comment below. I will see you in the next video about PostGIS.